Alright, so on number 5 it says to choose numbers from the list below and write a number in each box to create 3 true mathematical statements. Each number can only be used once. So it looks like we have inequalities, which would be greater than or less than signs. So that's an important word to remember, inequality. And then we have an equality, which is an equal sign. And we have all these different numbers. So what I'm going to do is actually I'm going to place them all on a number line right now. And that's going to help me keep organized as far as which numbers I've used and which numbers I still have left to use. So it looks like the greatest distance from 0 is 9. So I'm going to put 0 here. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's -9. There's +9. Each of those dashes represents 1 unit. The absolute value of -3 actually represents the value of 3. It's actually asking the distance of -3 from 0. So it represents the number 3. And so I'm going to represent the absolute value of -3 as right here. This represents the absolute value of -3. As far as when I'm using it as comparison to other numbers. -3 is the number here. Label that one -3. I have the number 0. I have the number -4. So 4 units from 0 in the negative direction. There's -4. I then have -7. 7 units from 0 in the negative direction, -7. I have the absolute value of 2, and I know that the absolute value of 2 is the distance of 2 from 0, so it would be a magnitude of 2, call that. So I'm going to write the absolute value of 2 above that. And then I have 9, and I have the absolute value of -9. Which in this case, that means that its distance from 0 is 9 units. So we also have on the same exact spot the absolute value of -9. And so as I go through this list, I'm marking there is only one pair that actually is on the same exact spot on my number line, and that would be the absolute value of -9 and 9. So those two values need to go in here as 9 and the absolute value of -9. Those are equal values. You can have it the other way around if you'd prefer to have the absolute value of -9 is equal to 9. That would be acceptable as well, but those two need to be matched up. That is something unique about an equal sign that is not the same with an inequality. If I had two values on an inequality, I would have to make sure that my inequality still opens towards the greater number. So you can't just flip-flop numbers back and forth on an inequality like you can on an equality where things are equal. So I need to now pick a number that is bigger on this side and a number that's smaller on this number. So these are both out. We've used those ones up. So we can choose. There's a ton of combinations we could choose. One of the things you could choose the absolute value of negative. So I'm just looking for the next biggest number that I have, and that just so happens to be the absolute value of -3 is greater than the absolute value of 2. You could have chosen a ton of different combinations as long as this number is farther to the right, and this number is farther to the left. Okay, as long as that is the case, you're good to go. There's a kabillion different ways we could have written that. And then of course a less than sign, so in this case this number needs to be farther to the right and this number needs to be farther to the left. So again, I can just pick the next two numbers. 0 is farther to the right. It's farther to the right of -3. I could have put a -4 in there, a -7 in there. Any of those numbers that was in our answer key choices would have been fine. So there's a lot of different correct answers on there. Just make sure that when you're looking, the direction the inequality is opening has to be farther to the right than the direction that it's pointing to. So you can use all 4 quadrants in the coordinate plane when making polygons. So just a quick review, you might see this on your unit test. This is quadrant 1, 2, 3, and 4. So So just take note, it goes counterclockwise, not maybe what you had thought before. So those are the quadrants, and it says to draw a rectangle on the grid by plotting these points. So let's plot each of these points, and we'll talk about where our rectangle's at. Remember, when we plot points, we have x, comma, y. That means left and right first, up and down second. It's very important. So my x-axis and my y-axis, positive values, negative values. Okay, so let's go ahead and start with -3, -2. So -3 in the x direction, -2 in the y direction. That's the first point. Then we have -3, 3, so -3 in the x direction, 3 in the y direction. And then we have 6, 2, so 6 in the positive x direction, -2 in the y direction. And then finally, 6, 3. 6 in the positive x, 3 in the positive y. There's our 4 points, and this represents our rectangle. All right. A few things that I recognize about this is that it is not symmetrical over in the axes. If I folded the rectangle over the x-axis or the y-axis, I would not have a perfect alignment of the corners of the rectangle, also known as the vertices of the rectangle. So we have completed part A by drawing the rectangle on the grid and plotting the points. It says, what are the length and width of the rectangle that you made in part A? So what we need to figure out is the length and the width. And really, most times we think horizontally for length, so I'm going to do it that way, and vertically for width. Sometimes we call them base and height, length and width, dimensions. I could have said, what are the dimensions of the rectangle? That would have been fine too. So I want to show you how to do this two ways. The first way and the most obvious way is by counting, and that works as long as the numbers are small. So as the numbers get bigger and as you get older and the word problems become more real life, this isn't going to be a good strategy for you. It's fine right now, but later on it will not be. So I can figure out the length and the width. So if I want to know how far it is from these points, I can count 1, 2, 3, 4, 5, 6, 7, 8, 9. Just count those again. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, I think that the length is 9 units. Doesn't say what type of units, so we're just going to say 9 units. And the width, how fat it is, 1, 2, 3, 4, 5. 5. The width, 5 units. Okay. So that would be one way to do it. I want to show you again the absolute value way, just in case you see this on your unit test, you understand how to explain it. One way of counting between two units that are perfectly aligned horizontally would be to use the y-axis as a reference point. So I know that this coordinate was at 6, 3. And so I know that it is, this distance can be represented by the absolute value of 6, the distance from 0. That 6 is. And this distance from here to here, this coordinate was -3. 3. And so its distance from 0 could be represented as the absolute value of -3. Because they're on opposite sides of the y-axis, if I add the absolute values, -3 plus 6, I know that's the same as 3 plus 6, because the distance of -3 from 0 is 3, the distance from 0 of 6 is 6, so 3 plus 6 is 9. So I know that this total distance is 9 altogether, which is what we had decided before. We can do the same thing with the width, except for now we're referencing the x-axis. If this is the coordinate 6, -2, then I know that the distance from here to here can be represented by the absolute value of -2. The distance from here to here can be represented by the absolute value of 3. So the sum of those distances could be represented of the entire distance itself. So that would be the same as 3 plus 2, which equals 5. There's a distance of 5. And it's important to keep in mind that if you're talking about distance and you get a negative answer, then you probably did something wrong, because the closest two things can get together is 0, meaning they're right on top of each other. There's no such thing as a negative distance. There's always space in between two objects, unless there is no space at all. Finally, it says, Mr. Novak asked his students to use the distributive property and the greatest common factor at the same time to express 18 plus 45 in a different way. Jude and Rachel came up with expressions below. So, which student followed Mr. Novak's correct directions correctly? Explain your answer. So Mr. Novak wants them to use the greatest common factor and the distributive property with the sum, 18 plus 45. When we're talking about factors, we're talking about numbers that multiplied to get 18. So we can make two lists of numbers, 1, 18, 2, 9, 3, 6, 4 doesn't work, 5 doesn't work, 6 is already on the list. So those are my factors of 18 and my factors of 45. 1 times 45, 2 doesn't work, 3 times 15, 4, 5 times 9, 6 doesn't work, 7 doesn't work, 8 doesn't work, 9's on our list already, so those are our factors of 45. Now Mr. Novak's asking them to use the greatest common factor. So there are a lot of common factors. 1, 3 are common factors, 9 is a common factor, but there's only one of those numbers that they both share in the same list that is a factor of both numbers and is the greatest of those factors, and that number is 9. And so it's been a while since we talked about this, but you can rewrite the sum by using the distributive property by finding the greatest common factor. So I know that 9 is the greatest common factor between 18 and 45. And I'm thinking of how many times 9 goes into 18 and how many times 9 goes into 45. And so you probably learned a little bit about PEMDAS or the distributive property. To check to make sure that this is an accurate statement, I can check, okay, well 9 times 2 is 18, 9 times 5 is 45. We can also think about what the actual sum of 18 plus 45 is. 18 plus 45. Sorry about that. I erased too much. I had a pudgy eraser. That would be 63. So we could do 9 times 7, which is also 63. So we have successfully rewritten that sum as a product. And it looks like Rachel has done a successful rewriting of the product, or sorry, of the sum like this as well, because I see that 3 times 6 is 18. And 3 times 15 is 45. So she successfully pulled a factor out, but she did not pull the greatest common factor out. If you're like Rachel and you don't pull the greatest common factor out, and then you notice, oh, 6 and 15 still share a 3 in common, I can write this 3 here, and then I can think about this new sum and take the common factor of 3 out of that one. And so I now have a 3 times a 3 on the outside and a 2 plus 5 on the inside, and I notice that I can eventually get to the same thing that Jude got, 9 times 2 plus 5. So this is a good first step, but it's not the greatest common factor that they've pulled out on the outside. And so yeah, that's basically what those blue words say. She didn't use the greatest common factor. She used a factor. She used the distributive property correctly, but she did not pull out the greatest common factor. The last suggestion I'll have for you to study for your test is to look over the problems that we did with greatest common factor as far as combinations of things. So like if I had 6 red balloons, 2 blue balloons, and 18 green balloons, how many combinations or how many bunches of balloons could I have with the same number of balloon in each bunch? I believe I saw that there was a question similar to that on your Unit 2 exam. So that's something you need to go back and review, watch the video on about greatest common factors, and maybe one about least common multiples as well. Go back and review that and take a look at it. That's really all I have for today.